Hi everyone, in this video today we are going to be going over reduced row echelon form. This video will take us through the process of rewriting our augmented matrix in reduced row echelon form. So, as we were doing earlier, we are going to start with a system of linear equations and rewrite it using an augmented matrix. We will then use our elementary row operations to get all our way down to row echelon form. From there, we will continue using our elementary row operations to get to reduced row echelon form and see why that is useful. Reduced row echelon form tells us the solutions to a system of linear equations. As you see in front of you, we have our example we will be working with. We will be taking our system, rewriting it as an augmented matrix, using our row operations to go to row echelon form and then reduced row echelon form. In reduced row echelon form will give us our solutions. We will now begin with our example. So if you don't have something to write with and write on in front of you, go grab that now. We're going to take that system of linear equations that I had on the last slide and rewrite it as an augmented matrix, which I have done. Now, we are going to take our elementary row operations and use them to rewrite this matrix in row echelon form. So take a second and think about which row operations you would use to get it so that the second and third term in the first column will be 0. First row operation I would use to get a 0 in this term would be to take row 1 and add it to row 2. Doing that, we get 1 plus negative 1 is equal to 0. Negative 1 plus 2 gives us 1. 1 plus negative 3 gives us negative 2, and 0 plus negative 5 gives us negative 5. For the third row, we will take negative 2 times the first row and add that to our third row. Taking negative 2 times 1, adding it to 2, will give us 0. Taking negative 1, multiplying it by negative 2, which will give us positive 2. Adding that to negative 3 will give us negative 1. Taking negative 2, multiplying it by 1, which gives us negative 2. Adding that to 5 gives us positive 3. And finally, 0 times negative 2, which is still 0. Adding it to 8 gives us 8. To finish getting this into row echelon form, we need to get a 0 in this term and a 1 in this term. So, see which row operations you can use to do that. Pause it, try to figure it out. For this one, we only have to do one more step. If we take row 2 and we add that to row 3, we get 1 plus negative 1 giving us 0, negative 2 plus 3 giving us positive 1, and finally negative 5 plus 8 giving us positive 3. Now we have an upper triangular matrix over here, zeros under all the leading ones, and in every row leading ones. So we are now in row echelon form. Reduced row echelon form is different from row echelon form. In reduced row echelon form, we have the first non-zero term in each row being a 1, and everything else in that column, above and below, if there is above and below, are equal to 0. So, to continue on and take our row echelon form to get it to reduced row echelon form, we need to get a 0 in this term, in this term, and this term. So we're going to start with trying to get a 0 right here. Think of the row operation you would use to get a 0 right there. If we take twice row 3 and add that to row 2, we end up with 2 times 0 plus 0, giving us 0. 2 times 0 plus 1, giving us 1. 2 times 1, which is 2. Adding that to negative 2 will give us a 0. And finally, 2 times 3, which is 6. Adding that to negative 5, and we get positive 1. Alright, we should be getting excited now. We are almost done. All we have left to do is if we are able to get this term to be 0, and this term to be equal to 0. 1's over here, 0's all up here, 0's all down here. We will have our answers. So here we go. I'm going to do this in 2 steps. Try to find the step that will give us a 0 in this term without changing anything down here. If I take negative row 3, add that to row 1, I get negative 0, or just 0, added to 1, giving me 1. Negative 1 times 0, again, still 0. Adding that to negative 1 leaves me with negative 1. Negative 1 times positive 1, adding that to positive 1, which gives us 0. Negative 1 times 3, negative 3, plus 0 giving us negative 3. Now, looking at this matrix, how do we get a 0 in this term? If I take row 2 and add that to row 1, we get 0 plus 1, giving us 1. 1 plus negative 1, giving us 0. 0 plus 0, leaving us with 0. 1 plus negative 3, giving us negative 2. Now, the first term in each row, non-zero term, is 1, which is what we wanted. Everything in the same columns are all zeros. And on the side over here, we have our answers. Remember that our matrix that we had rewritten was just a different way to organize the information that our system of linear equations told us. Reading across this first line, it tells me that 1 times x plus 0 times y plus 0 times z is equal to negative 2. In other words, x is equal to negative 2. The second line tells me 0 times x plus 1 times y plus 0 times z is equal to 1, which tells us y is equal to 1. And finally, 0 times x plus 0 times y plus 1 times z is equal to 3, which gives us z is equal to 3. So, doing this by hand, it gives us our solution set to our system of linear equations. What we'll come to find out is that a calculator will be able to do this really, really quickly, and if we use our reduced row echelon form, it'll tell us our answers immediately without having to use substitution. Thank you for watching. Sorry if this was awkward. This is my first time making a video. Hopefully I'll be doing it again, and hopefully you guys don't hate it, so you'll watch them again. Thank you.